In the news, it often says a new Earth is found or a habitable planet. We don't have that. Most of those are computer simulations. We're very far even from identifying a habitable world. Based on a known planet, we might know the planet's size, maybe its orbit, how far it is from its star. But honestly, we don't know if the planet is habitable, or if humans could live there, or if there's any kind of life. That's still quite a ways off. We have to improve all of our technologies again and again to be able to really study those habitable worlds. The first hurdle is really just what we call precision. Let's imagine for a moment that you're going to build a table at your house. And this table has to be, let's say, 6 feet by 3 feet. You might be able to figure out how to do that. But now if I say, well, that table has to be 6.0000 feet by 3.000 feet. Maybe you could probably figure out how to do that. You have to have a very special measuring tool. But now I pose to you, you have to be able to make that measurement. I mean, you wouldn't want to do this, it's just a theoretical thought. To 6.00000000 feet. Like, how would you even measure that? And so our problem in studying and finding tiny planets is they're so small. And we have to study their atmosphere, which is like the skin of an onion on an onion. It's that small. And so having to measure something to many decimal places, that's the fundamental challenge that we have. But we're working on it. And it's all within the laws of physics, so it's doable. And engineers think they can build very sophisticated space telescopes and large ground-based telescopes to do the job. And what you're asking about is when we do the job, what will we look for? I mean, the first thing is we want to know the temperature of the surface. The planet can't be too hot. If it's too hot, bonds can't form between atoms, and molecules can't form, and complicated molecules cannot form, so we can't have life. If it's too cold, everything will freeze out, water and carbon dioxide, and those greenhouse gases that we're worried about on Earth, if they're not there at all, if they're frozen out, then the atmosphere, the planet will be too cold, and there's not enough, we think, molecules that can react and for life to evolve. So we're looking for a planet that's about the right temperature. But the atmosphere acts like a giant blanket. It's like a greenhouse. And so we have to understand the atmosphere to know, to infer what the surface temperature might be like. We're also looking for water because on our Earth, all life as we know it needs liquid water. And we can't see liquid water on a planet, exoplanet far away, but we could see water vapor. And water vapor on a small rocky planet indicates there's a water ocean. And even after we could establish those two things, that the planet appears to be the right temperature, that it looks like it has water, we'll look for gases that don't belong, gases that might be made by life. On our own Earth, oxygen is our gas made by life. Without, our atmosphere has oxygen to 20% by volume. But without plants and photosynthetic bacteria, there would be no oxygen at all. And so we're hoping that, I'm hoping personally, and I just say this in jest, but it's partly serious, that there are other intelligent creatures on another planet orbiting a star not too far away who has the kind of telescopes we're hoping to build. And they look at our Earth and they see oxygen. And they say, wow, there has to be something about that planet that's not normal. Oxygen is reactive. It shouldn't be there. It should react away immediately. And that they infer that something unusual is happening, and hopefully they can deduce that there is life on our Earth. And we hope to do that. And we have a whole list of other gases as well that we're going to be looking for.